Because of its size, cargo, and geographical circumstances, a vessel may pose a threat to the environment or the economy. In that case, local law can require an escort tug. During these escort procedures, multiple tasks can be demanded from the tugs to maximize safety. The working principles of an 80-ton Sterndrive tug and an 80-ton Rotortug differ substantially. The difference between a Rotortug and a Sterndrive is immediately visible when the tug is required to apply braking force on a vessel sailing at 10 knots. This maneuver is called the transverse arrest. At a towline angle of 0 degrees, the Sterndrive is capable of delivering 80 tons of braking power. The Rotortug, with its 3 maneuverable thrusters, can deliver 95 tons of braking power. The Rotortug has significant advantages from its patented configuration. It can apply both steering and braking forces onto the escorted tanker at the same time. While using indirect escorting with a towing line angle of 15 degrees, the Rotortug simultaneously delivers 106 tons of braking power and 30 tons of steering power in the desired direction. The Sterndrive tug delivers 100 tons of braking force and a maximum of 10-ton steering force while indirect towing on an 8-degree towing line angle. Changing this angle will result in a drastic change of applied forces. In case of an emergency, the Sterndrive tug needs to make a choice to either brake or steer. But there's another issue that may cause a possible safety threat. A Sterndrive tug in maximum braking position has a heeling angle of approximately 12.5 degrees. This means that it is at the turning point of deck immersion, which may lead to a significant loss of stability. In comparison, the Rotortug will only have a heeling angle of approximately 8 degrees in maximum braking position. At a 45 degrees towline angle, a Sterndrive can apply 50 tons of braking force and a steering force of 40 tons at the towline. In this position, the heeling angle is 12.5 degrees of the Sterndrive, which is again close to deck immersion. A Rotortug can deliver 100 tons of braking force and 56 tons of steering force while operating under a 30-degree towing line angle. The heeling angle of the Rotortug in this position is again approximately 8 degrees. The configuration of the 3 thrusters enables a fast reaction time in case of emergencies. The Rotortug can maneuver itself using the thruster closest to its towing point. A Sterndrive tug has its thrusters at the opposite side of the towing point, making changing position a more time-consuming task. The 80-ton Sterndrive reaches the highest steering forces operating at a 90-degree towing line angle, where it can apply 52 tons of steering power only. No braking force can be delivered onto the escorted vessel in this position. The Sterndrive tug needs its thrusters to counteract the capsizing moment created at this towline angle. When this counter effect suddenly disappears, the heeling angle may bring the tug in danger of capsizing. Reaction time to position the Sterndrive tug in a maximum steering position is time-consuming. The 80-ton Rotortug can swiftly reposition to a 40-degree towing line angle where it applies 67 tons of steering force while still being able to apply the substantial braking force of 85 tons. Because of its unique position called combined arrest, the tugboat creates a very safe escort situation with a heeling angle of approximately 4 degrees only. The Rotortug is in full control of the assisted vessel within 15 till 40 degrees towline angle, resulting in braking and steering at the same time, minimizing emergency response time. There is never slack in the towline. A slack towline can result in peak forces once sudden forces are applied. The Rotortug not only has excellent escort capabilities, it also has significant advantages while performing ship handling operations. A Sterndrive needs to reposition itself before being able to apply forces on the towline. She will exceed the width of the tanker during the berthing operation. For berthing a tanker, a connected Sterndrive tug needs a second vessel to apply sideway force at low speed. Therefore, a tanker or bulk carrier is often berthed with 4 tugs using the push-pull system. A Rotortug can apply indirect force to the towing line at 65 tons at 0 speed, making any second tugboat unnecessary. This unique maneuver is called rotoring and is in fact pushing into the tow line when berthing the vessel. Modern towing winches and synthetic tow lines make it possible to tow on short distance even with very heavy seas. The Rotortug is capable of indirect pushing and pulling upon request of the pilot, ensuring minimal response time. During this maneuver, the Rotortug will remain within the width of the vessel. The Rotortug can swiftly change its position and apply force to the towing line at all times and in any position. Rotortugs minimize vector response times, offering maximum control even in more severe weather conditions. No pushing in the side of the tanker is required anymore, and therefore there is no danger of damaging the hull of the assisted vessel. When pilots want the Rotortug to push anyway, the risk of ventilation is minimized due to the different positions of the thrusters. Ship handling duties can be performed with 2 tugs only most of the times, yet another advantage. Rotortug, designed for the future.